Welcome back. This is Microsoft Virtual Academy C# Fundamentals Prep. This is module 3. All right.
It's already been a long day.
It's great.
Exactly.
All right, so we have a lot to cover again, and we'll do the best that we can. Let's begin with kind of an agenda here. What are we going to cover?
So the key objectives we're going to address in this particular module is controlling programmatic flow. So really drive into how you can control what executes and when. And then we're going to revisit manipulating types and some of the ways we can control that, and then manipulating strings.
Pretty valuable. This is something that developers do all the time.
Exactly.
All the time. These are the fundamentals of fundamental. Keep going.
So, controlling programmatic flow. The C# language includes many statements that can help you control program flow. You've got 3 primary classes of those statements. You've got your selection statements, and examples of those are if, else, and switch. You also have iteration statements. Iteration statements allow you to repeatedly execute blocks of code, and you can implement logic to control those. And then you have jump statements.
And jump statements allow you to break that flow.
Exactly.
So something is going on and you want to interrupt it for one reason or another. And all these different ones like break is probably the easiest, continue, and continue is great actually because it allows you to go right to the next. And then in the return,
optimize an algorithm basically.
Yeah, that's exactly right. And to hop through an iterated list, and then return, of course, for those methods that are returning something to the caller. And so there's more than that, and we'll go through all of them.
Sounds good. So let's have a look at the if statement. So the key thing about the if statement is it evaluates an expression. And this expression must return a Boolean value, either true or false. There's no truthy or falsy here. This is just true or false. And
or falsy.
It allows you to make a decision around which block of code you're going to execute or whether this block of code is going to execute.
If statement obviously is important because there are times when you don't want something to happen. So you just wrap it in an if and you create the Boolean expression.
Exactly. So if we look at the sample code on the right-hand side here, we can see if value is equal to 1. Now you notice that there are 2 equals there. That indicates that this is a Boolean equality check as opposed to an assignment. If you had a single equal there, we'd actually be trying to put 1 into the value. Interesting thing about the C# compiler is it knows context and it will not allow you to do an assignment by accident. In C, you could actually do a assignment in this scenario where you could say value equal 1, and it would actually return the value of that expression, which would be 1, which the C compiler would turn around and say equals true, and would then actually go and process. The C# compiler prevents that by turning around and saying you cannot do an assignment here, it has to evaluate to a Boolean expression.
So I see if, and now I see else if, and I see else. That's the full family of the if statement?
That is pretty much the full family. You can embed ifs within ifs, but this is one of the most common scenarios that you'll see. And so what's going on here is this is kind of an efficiency play.
You mean else if is?
Else if.
So else if isn't just kind of syntax candy. It's not just something you do because it looks cool.
If we actually look through and look at this whole string of commands and work out exactly what's going on, we can see, first of all, it's evaluating if the value is equal to 1. If the value equals 1, then it'll do console write line 1.
And then it evaluates else if?
Then it basically exits. As soon as it hits the else if.
This is the efficiency.
Because the first expression was true, it executes that body and then moves beyond that entire block of if statements.
And I might want that efficiency because this is very, very simple, but it might be a Boolean that says, is anyone on the first floor? And it goes through a bunch of sensor arrays and detects, right?
Yep.
And no. Okay, so else if anybody on the second floor, another expensive, and you want it to stop if there is somebody on the second and not do the third, fourth, and all the way to the 100th floor. You want to be able to narrow that down. That's the difference of serial ifs versus else if.
Exactly. The else if is optional evaluation of the secondary and tertiary and so on expressions in the if block.
And else runs if all of the evaluations don't pass.
Exactly.
Nothing is
It's
there.
your catch-all. So if no preceding expression is true, then the final if statement or the else statement, I should say, will execute that body.
And just like we have shorthand for everything, we have shorthand also for a simple if statement. And this is the ternary operator. And the ternary, it's fantastic. I love it. I think it's a quick way to be able to bring your code up. It can be overused. You know, you definitely don't want to nest them. I've seen that, and it's hard.
Some people hate it. Its roots, it was in the C language, and so because C# is based on the C language, it inherited that capability. But in effect, what you see on the right-hand side here is an if-else block, plus you see the implementation of a ternary within the console write line.
So those two are identical.
They do exactly the same logic and result in exactly the same output.
So you can see why you would want it, because it collapses your code and, you know, makes it skimmable and maintainable.
Yeah.
But be careful.
And you basically read a ternary in the same way as you would read an if statement. So you can see there's an expression there. So you'd say, if value is equal to 1, do 1 or not 1.
And then what's the syntax for else if in a ternary?
There isn't.
So that's what it's just for the simplest if statement. You can kind of nail it. I use it a lot for value assignments. You know, you're going to assign it to this if that. Easy enough. That way you can have a default or some sort of fallback.
Exactly.
Okay. Let's combine the next demo together.
Okay.
And talk about do whiles for a second, and we'll pull them all together in one.
Sounds great.
Do whiles are just while loops in general. They show up everywhere, right?
Yep.
A while loop is important for when I'm evaluating a Boolean statement, exactly like an if statement would do. A while allows me to continue doing it again and again and again while it continues to return true.
Exactly. So it's effectively repeats the expression evaluation each iteration to determine whether something must continue, and you have that body. Now, there are the two syntactic styles here. There is while, and then there's do while. The key difference between these two is that the while statement evaluates the expression first before executing the body. So if that expression is false, then the body may never execute, or if it's false, it will not execute. So
can I type something for a second? I want you to. What if I do this? What if I do a while?
Just cut to his desktop.
And I do a let's say a console write line of Darren. What if I could do this, right? A Boolean true is true.
Exactly, and this will run forever.
That's right. If you're wanting to burn down a machine, this is a great way to do it. But don't console write line. Do something very, very expensive.
In fact, this is reminiscent of the first program I ever wrote, which is, there's a store in England called Dixon's, which had computers in it. And when I was a kid, everybody would go in there and do, it was in BASIC, so you would do print your name, and then say go to 10, which was the same line as print. And so your name would be scrolling up the computer, and you'd be like, yes!
It's developer vandalism.
Exactly.
Nice. All right, so I could do the same thing. If I have a variable, it's brutal not to do it like that. Exactly. How many times have you done like even for if, you say if false, right, so it doesn't run, so you can do some debugging.
Exactly.
But here, what you would do is say something like this, or you would make it based off something. You want to end a while.
Exactly. I mean, there are times when you use these looping constructs, particularly in message-based systems, where you're starting up an application and it's going to keep running through. But what you want to ensure is that you have something that pauses your processing, because otherwise you'll tie up your processor all the time as it's going through that loop time and time and time.
This is I don't want to say it's an amateur mistake, because I make it all the time, which maybe is okay to still say, but it is certainly a new developer mistake that happens frequently, that you don't realize a while holds the process.
Exactly.
And it can really kind of mess up the performance of your application. Do while is a little different. It's just the reverse. It makes sure the first one runs, and then it continues to operate like a while after that.
Exactly.
Makes sense to me. So now we have iteration statements, and they're kind of like a while, right? Because they do allow you to repeat. And so we have for. That's the iteration statement, I think.
Sure.
And so if we were to look at a for, let's look at the demo for a second. If I had a simple for, and I love using this snippet for this, because getting the semicolon in just the right place, sometimes I don't get it right.
That looks like code generation to me.
Yeah, well, it's not though, right? It's just a snippet coming from Visual Studio. And anyway, so a for, the syntax around for has 3 core pieces. Basically, it's starting point, and so that's where I am right now. I equals 0, and so this is going to iterate through a series of numbers, and it's going to begin at 0. The next one is going to be the condition of when it's going to stop. And so until is kind of what
So that
says.
condition is being evaluated each iteration?
Every single time.
Okay,
Every
excellent.
single time. And it's interesting because it evaluates the variable, but that condition can be very complex if you want it to be.
Yeah.
And then I++ is basically saying after you read it, add another, increment it by 1. And so it continues going 0, 1, 2, 3, whatever it is.
Oh, is that another of those
we set to
shorthands?
It is certainly a shorthand.
Oh, that's awesome. So if we wanted to just go through this loop 10 times, what would we put in for length?
We would put in 9. It's 0 based.
No, because we got less than.
Oh, we have less than, yeah, so good. Yeah, thank you, that's perfect, yeah. So you could change it to this and then mess up your logic. All right, good. Right, so 0 to 10, it would never hit 10 because it starts at 0 and does less than.
The other interesting thing is here, you could also, during the initialization clause, you can actually initialize more than one variable. So you'll see a canonical example would be int I equals 0, comma, int j equals 0. And then on the increment side, we could also be incrementing j.
Which is a
It's a comma.
Comma semicolon. There we are, thank you.
So basically, you can go through and evaluate multiple variables and iterate through at the same time.
Yeah, a lot of interesting power there. Now, this is good, and you would do this a lot. Like, I have to do this 10 times. I have to go through a list of 10, and I want to reach out to them. But I can use other iteration statements as well, right? So
exactly.
I would say one that is very common, not for, but
for each. And so for each is very interesting in, it speaks back to collections. And so a collection are those lists that we were dealing with earlier on. So a list of T, a list of ints, and so on. Effectively, it allows you to move through anything that is enumerable. And there is an interface called IEnumerable that these collections implement that allow for each to work over those.
Collections, lists, arrays, everything is enumerable if it holds more than one.
Exactly.
Yes, and so now I say for each, and what's nice is, if let's say these were, this is a list of dogs, I can, these would be objects that I would be iterating through. That's very valuable.
That's an interesting syntax you've got there. That's an initializing list.
It is. This is yet more shorthand, isn't it?
Exactly.
Yeah, I could, instead of creating an array and then adding to it, I can create an array and in its initializer give it its initial members. And so that's what I've done.
But what type is var?
In this case, it'll talk about, whew! Well, var is a new array, and the array is of type integer based on what I initially give it.
Oh, so the compiler has implied what you mean.
This is one smart compiler.
Exactly. So this is part of the developer productivity that's going on. There could have been a whole bunch of typing that...
In fact, let me just go and show. This is the same, that I can explicitly say that it's an array of integers,
yep.
But it's inferred based on its membership that
exactly.
I've given it. And then I can go even further, and of course, I don't have to use var. I could explicitly say the type, and I could go even further to stop it here and start adding to it, changing its size, making room for it in the array. Very difficult, time consuming.
Exactly. I mean, you could turn around and say, the array has a size of 7, and then assign each of those values to the index.
That's right. That's exactly right. It's there as well that it says it can hold 7, all implied in the constructor.
Exactly. So as you can see, really, really powerful from that perspective.
Not a for each loop, but nifty nonetheless.
Exactly.
Yeah, absolutely. Okay, so now I iterate through it, and I only iterate through it one time, and that gives us some neat things that we can do. If I'm inside this list and I say, if item, because remember, item is going to be the individual ones that I loop through them, I can say if item. And I'll just check to see if it's even or odd. And so let's say it's odd, and this is the modulus operator. And so
Excellent.
If modulus 2, which would mean it's even, and then I can say continue. Now this is an interesting keyword because it allows me to say all the other stuff that I've got down here, which is all the hard work, doesn't need to be done for even numbers.
Oh,
right?
So we're just skipping. We're skipping straight out.
That's right. I don't want to jump out of this loop. I just want to jump to the next one.
Oh, okay. So say we were on 1. 1 wouldn't be an even value, and so we would loop back round and move to the next item in that list.
That's right, and it's handy because I don't have to say go next or anything like that. I don't have to have a gigantic if statement that wraps everything in it and makes sure that it's odd or even.
It's very succinct.
Let's say that once I hit, let's say it's not going to be even. If item equals 5, I need to stop. right? I want to completely stop. So I want to break out of this loop altogether.
Okay.
I want to break out of this loop altogether.
I see what you did there. That's clever.
That's a triple entendre. And so right here, where I have continue, I'll say return. And return, with that will break it all. That is not what I meant to type. But that is a type of break statement.
Well, return will actually exit the X method, won't it?
Yeah, so if I had to do this, would be done on every item, and when it's finished, it'll to do more. But if I pull a return right here, it exits altogether, and the method stops execution altogether.
So that really jumps the execution out of that method back to the caller.
That's right.
That's awesome.
So return is amazing, right? It's basically stop here.
Yeah.
But what if I didn't want to do that? All I want to do is stop going through the list.
You mean you still want to execute your to do more?
That's right. I still want to execute to do more. How do I do that, but still stop the for loop?
Do you want to break it?
I want to break it. I've broken code my entire life.
Exactly. Despite the compiler's best efforts.
That's right. It's me versus the compiler.
Indeed.
And so it's simple enough. I just say break. Break says to the compiler, whatever you happen to be iterating through, stop. And go to the line that's right after it. And so basically this is a jump statement that says go to whatever is right after it. I could, I suppose, use the keyword go to. I'm a VB developer, so I certainly know go to. We had go tos everywhere. And go to allows me to set up a label, just like it did in VB. Set up a label and say go to label, right? And I could set up the label down here, like so. That's the way it works. It would jump exactly the way I want, but there's no implementation, so here I put a return below it. What is the problem with the label? I don't see this syntax in developers' code, even though it's supported. It seems odd. I think, for one, it's there because of kind of the legacy.
C legacy, yeah.
Yeah, the legacy of the language.
Absolutely.
But we don't see it though.
We don't.
We don't.
Pun intended.
We don't see. We don't see sharp it.
We don't see it, and it's because we're striving in our code to be very predictable about our execution paths and where we go.
Is that right? We're 40 minutes over? That can't be right.
Oh, no, we're not. We're not distracted.
Like, wow.
We have a countdown here that tells us how much over we are, and we've been over some, but we were surprised to see 40.
We're setting a record.
Okay, coming back to where we were. So labels, go-tos, and so on.
Yes.
So we're striving to make our code readable, and we're striving to have very clear execution paths through our code. Go-to allows us to disrupt the execution path and jump around. We could have label could actually be above the for each, and go-to would push execution to be preceding the for each, so we go back through the for each again.
Yeah.
That would be confusing, wouldn't make much sense. And so
and potential for all kinds of trouble like infinite loops.
Exactly. And so what's been found over time is generally it is a poor idea to use go-to.
Now let me restate it with a little more passion. I am yet to see a scenario where go-to is the appropriate final solution. It's just the way it goes, and you can use them and they'll operate the way that you expect them to operate. But there are many other conventions and many other constructs inside C# that honestly, they are the better solution when it all boils down to it.
Sure, there is an interesting scenario in the switch statement, which we should demonstrate shortly.
Yeah.
Where you can use go-to case within a switch statement to actually jump to a different case within the switch. So if you had a certain set of values where you wanted to combine these two case statements, that you want both actions to occur for a specific value, then go-to case can be used to redirect from one case statement to another. But again, it's very much an edge case. And
you know what? I don't even want to talk about it anymore.
To Jerry's point,
I do not like go-to.
To Jerry's point,
I don't like it at all, Darren.
I'm going to hit you. To Jerry's point, there are not very common scenarios where you want to use it, but it's there, and so we touch it.
Well, it's important to understand it because you might run across it. Yeah,
yes.
You don't want to be confused by it for sure. Now, I could return that would stop the execution of this method, but I could also stop execution of this application. I could throw an exception that can really cause some damage, but it's another way of jumping, right? So I could say throw, and you can't just throw. You have to throw something. What are you going to throw?
An exception.
An exception. Oh boy, there was almost a visual. So, I've just thrown an exception. Of course, we'll talk more about what exceptions are in a little bit. But this is certainly a way of interrupting flow.
Now, you mentioned before that this would exit the entire application. Mm-hmm. That would be true if it wasn't handled. You know,
oh, that's exactly right. I mean, honestly, we're a little bit ahead of exceptions, but certainly not handling an exception is the way you terminate an application by mistake. But exceptions can also be, they aren't necessarily a violent way of using it. That can be a good way of communication, depending on how you actually use it. If you have a violation of access or some sort of security violation, an exception may actually be the right way. So only your code that handles those exceptions properly continues, and anybody who's tinkering with your app, they get an actually thrown exception that causes all kinds of mess inside their app. Exceptions are powerful. We'll talk about them in a little bit.
Absolutely.
All right, so this is more about throw as another jump syntax. Excellent.
So we needed to do a quick demo of the switch statement.
Yeah, so let me pull up and build one real quick. And it's nice. There's a couple things that you can switch, by the way. A switch statement is sort of like an if statement, wouldn't you say?
It is. I mean, basically, you would use a switch statement when you had a number of different conditions that you wanted to check. It's a much more efficient and succinct way of stringing together a lot of those checks.
Let's see. I have a dog named Barney, Lassie. I'm trying to think. Snoopy. Think of another dog. I need one more.
Old Yeller.
Yeller. How do you spell Yeller? Yeller?
That'll do.
Yeller. All right. I've never heard of a dog named Barney. I'm a little embarrassed by that one.
Okay, then you should probably spell Lassie with two S's.
Are there two S's in Lassie?
See, everyone's a critic, isn't it?
All right. So we'll start with a switch statement, which is sort of an if statement, of course. But one of the things that it really uses, or really goes against, is enums. Enums are a way of us to create strongly typed options. That's a great way to think about it. And what?
I'm just wondering why the compiler's complaining.
Is it? It's actually asking if I want to do a symbolic rename from Lassie to Lassie.
That's crazy.
All right, well, let me...
That's because it's so helpful.
All right, so now the syntax for switch is actually very simple, but this is where a snippet really does help.
Yeah, exactly.
Let me type switch, because that's what I'm going to build, and I'll do a double tab. That's how we do snippets. And right now, this is the base implementation of a switch statement. But now I'm going to say I want to make a switch statement against the dog's enum. So I'll say dags. I'll say dogs actually. And as soon as I do, it will look at all of the possible values of enum and then break it apart like this for me.
That's pretty powerful.
It's really powerful. Well, it certainly saves a long time, especially on an enum that has several members in it.
Indeed.
Yeah. Now, the first thing you would do is remove that, because you can't do it to an actual enum. But I would say there's a variable that says, some type of dog equals dogs dot, and then we'll say it's going to be Snoopy.
Awesome.
Yeah, so far so good. In fact, just to make it clear and nice, I'll call him Snoopy. And that will be what I'm switching on. And the switch, in a lot of ways, is if else this, if else this, if else this, if else this, with the break to indicate don't continue.
Okay. So what if we wanted to treat both Lassie and Snoopy the same? How would we do that?
So first let me implement Snoopy, and then I'll show you exactly what's going to happen. So here, let's say it's going to be a console write. It'll say, hi, Snoopy. And now, this is all right, but yeah, you're right. Lassie comes in, and so we'll make it more generic so Lassie doesn't feel bad. Lassie comes in, nothing is said to him, right? Only to Snoopy so far, but we want both dogs to be able to have a little greeting. So I can take this break, and what actually happens is it falls through from one case statement to another. So although I haven't implemented Lassie, what I really have done is I've implemented Snoopy and allowed Lassie to fall into Snoopy.
So what if you had a hi Lassie underneath dogs.lassie? Would you be able to remove break and fall through to Snoopy that way?
Like this?
Yeah.
Well, I wouldn't.
Okay.
I wouldn't. As long as there's no implementation, I can fall through. As soon as there is any implementation, I have to implement break and close the body, basically.
Okay, so if we wanted to do call the Snoopy afterwards, this would be when you would use that hateful construct called goToCase Snoopy.
You could. I won't. All right, so now let's say somebody comes up here and says there's one more dog. One more dog. It's Fido. Fido comes in. Now, I don't have a case statement specifically for poor Fido.
Oh, goodness.
So what happens now when somebody comes in and they define Fido? The switch statement is looking for Fido. It says, is it Lassie? No. Is it Snoopy? No. Is it Yeller? No. That's why we have default.
Okay.
Default is sort of like the else in an if statement. However, default is optional. I don't have to do this. What I often do is, if I have a default, I throw a new exception of some kind that says not supported.
Okay. So you're basically giving a hint to any developer that comes in that this was an unexpected or unhandled situation,
right,
and you want to, they should be dealing with it.
Right. It's not necessary that you throw a not supported exception, but it's a good way of communicating back to the developer that they're in territory that isn't covered by this code.
So really what you're advocating there is a sort of defensive programming stance, that whenever you're coding and building methods and so on and so forth, don't think about just the golden path execution. Also think about, okay, what could possibly go wrong, and put some defensive aspects in there.
Yeah, you got it exactly right. That's
awesome.
perfect. And it's interesting because now it's telling me, see this little green underline, it says unreachable code detected, and it goes back to what we were talking about in that jump statement.
Yeah.
Throw stops execution. So it's saying it's never going to reach break. Actually, it's never going to reach anything after it, and so that's the end of that. So why have break there? You don't have to. It understands that that throw takes the place of break.
So basically each case clause needs to be completed by a jump statement.
That's exactly right.
Okay.
That is exactly right. I could put a return, I could put a throw, I could put a break, whatever it is, I just need to end the body somehow.
Okay, that's awesome.
Yeah, it's very powerful. And again, this is just the compiler helping us out. That's why it was underlined in green instead of red. It would still go ahead and compile. All right, so I see that we're going to be talking about casting. I want to kind of build out a scenario again, and I want to do some inheritance, and then I want to kind of cast into those so we can see what they do.
Okay, that's awesome. Just to point out to those guys who are sort of following along with us, we're skipping some of the slides because we want to spend as much time as we can in Visual Studio and sort of show you these things being developed live. So all of the content will be, or is in the deck and so on. It's just a lot more interesting, I think, for you guys, for us to actually be working in Visual Studio.
Oh yeah, absolutely. I think so too.
Yeah, it's more fun for us too.
Developers, this is how developers think. You know what I mean?
Exactly.
It's just right in their language, and it just makes more sense.
Yeah.
All right, so I've done something fun here. I've created 3 classes, animal, dog, and poodle. You can see the hierarchy coming. So we have the base class of animal, and then a dog inherits from animal, poodle inherits from dog.
Awesome.
What should we do next?
Well, I think what we should do is just sort of experiment with some of the casting and see which ways we can cast and which ways we can't cast.
Yeah, I think that's a great idea, because you'll be surprised to see what you can't do.
Exactly.
that's for sure. Let me create a little, keep going, I'm going to just...
So why don't you create a method that takes a type of animal as a parameter? And then we can experiment with what we can call and what we can't call and so on. That would be interesting.
All right, so I'll create a method. Isn't that funny? Boy, that's so
I'm in your mind.
it takes an animal, and so the type that's going to pass in is animal.
Yep.
And there it is.
Okay, awesome. So up in X, why don't you start creating some instances of these types?
All right. This is going to be a dog, and this is going to be a poodle.
Hope you're enjoying watching Jerry type as much as I am.
Are you?
Yeah, it's awesome.
I know it.
There's actually been a very few typos, which is...
It's just crazy because
good.
this keyboard is it's
You're obviously
virtual.
not thinking about the thousands of people that are watching you type right at this very moment.
That is be the last one that's typed correctly. All right, so here we are. I've got all 3 of them, and now I want to call take animal. It doesn't really matter, right? This is just something.
Okay, yeah, sounds good.
And so now I'm going to pass in, and what can I actually pass to take animal?
So the parameter is specifying that it will only accept arguments of animal.
So I know that will work, right?
Yep.
No red underline? No red underline.
Once it catches up.
Yes.
Okay.
I'm faster than the compiler.
That's incredible. It seems incredibly unlikely too. But we've been talking about this object inheritance, and what we've said is, well, a dog is an animal, and we've stated that in that inheritance right there.
That's right.
So why don't we try and pass dog into take animal as well?
All right, DOG, red underline, doesn't appear.
So what we're finding out here is, because dog can be treated as an animal.
Good.
And it is supported through the inheritance structure. We're actually able to pass a dog to a method that takes an animal.
Yeah.
That's really interesting. Why don't you define a couple of properties in, say, dog or poodle?
Oh, okay, sure. Let's see, all animals have, here we go. You killed it, man.
Exactly. That's
all animals have temperature,
okay.
let's say, because they're alive. All dogs go to heaven. All dogs have a name. And a poodle has a shaver. All right? The person who grooms them.
Exactly.
A groomer.
Groomer. That sounds better.
Yeah, then shaver's funny. All right, there you go.
Okay, so now we're inside take animal, and we've got an instance A. So what can we do with A?
Well, we can treat it like an animal.
Okay, so what does that mean?
Well, because it's only an animal at the highest level, the only thing I can really do is interact with what's defined for the animal. Not dog, not poodle, so we have temperature.
Okay.
So A.temp, there we go, A.temp equals 10.
Okay, that's interesting.
Yeah.
But what we've set above on the line, I wish we had line numbers,
Me too.
the take animal has been passed a dog.
We're going to have line numbers now.
It's incredible. It's almost as if you understood what I said.
Did you see that quick launch up there? Visual Studio 2012, new feature, very awesome.
That's very awesome.
Very
Sorry
awesome.
for all you guys who are still on 2010.
Wah, wah. All right,
So-
I'm passing in a dog. I'm not passing in just an animal.
You're passing
There's
in
a
a
lot
dog.
of fidelity to a dog. I want that.
Exactly. How can you get to it when you have just an animal
So
inside that method?
I'm going to guess var dog equals animal, and then I'm going to cast it. Of course, I know the casting syntax.
So do the casting syntax. See what,
As dog.
well, let's try the other one. Let's try the one with where you try and cast it first.
All right, let's do it like this. Dog. So two types of casting, both cast to another type.
Exactly.
Go ahead.
So if we look at that, is that safe?
It is safe.
It is safe.
It is safe.
What if we just passed in an animal?
If I did just pass in an animal, it would not cast. And for that reason, it's safe. But it's not safe as far as the stability of my application.
Exactly, because what would happen?
It would not only would it fail, it would raise an unhandled exception that would just blow the world.
Invalid cast exception.
Right.
And so that could be problematic in terms of if we want take animal to be able to go through and reach into implementations that are in dog and implementations that are in poodle.
Which is nice. If I had dog dot, I do have name, which is special only to dog.
Exactly. So you could get that. So how can we, within the context of take animal, perform a safe cast that doesn't interrupt our program execution?
We needed we want to have the same effect, but we want to do it safely so we don't raise exceptions and blow up our application. Perfect. All right. So I don't want to do it this way. Perhaps I want to do it this way.
I love that dog name, by the way.
Yeah, it's good, isn't it? It's real catchy.
Exactly.
There we are. All right, so here we have, instead of putting the type in parentheses before the object, now we say the same object as the type.
Okay, so that seems pretty awesome. But what if A isn't a dog? What's going to happen? Say if we passed in a poodle. What?
Well, what we do know, because partly we were just talking about it, is it's not going to raise an exception. What I don't want is for something to just blow up for me. But I do need to test it still.
Yeah, because
So-
what is dog going to be right now?
It is going to be null.
Oh.
And null is going to represent failure.
And so what happens
So
if
let
we
me go
try
up and make a quick change. I'm going to pass in a poodle. Right? Poodle
Yep.
cannot cast to dog, but it can be cast to an animal. So I can pass it into the method, but I can't
doesn't
cast
poodle
it to a
inherit
dog.
from dog?
Poodle, darn, this is too deep. Yeah. Let's see, I need to change it to bird.
No, do dog.
I'll just pass in the animal. The animal cannot be passed.
Okay, fair enough.
Yeah.
Yeah, exactly. Okay, so we would have dog equals null. And what happens if we try and invoke a method or a property on a null?
So right here, setting dog's name to Darren would fail. I would get the exception then. It would be a null reference exception that says dog is null.
Okay, so clearly we want to protect ourselves against that happening.
Simple if statement. If dog does not equal null. And this is my way of communicating with that as cast to make sure that it returned an actual value.
Yeah. Now say we had a whole bunch of expensive operations that we were going to do. We could encapsulate them all within that dog equals null, but say we wanted to preemptively check is a dog?
Right, before we do anything, don't set it to null, just don't do anything.
Yeah.
Yeah, exactly. But now we would precede the line with a check to see what type it really is. Now we know it's an animal, but it could be a dog, it could be a poodle.
Yep.
All right, so what do?
We use is.
Is and as, they're all very good friends with each other.
Exactly.
All right, so if it is a dog, then we do some operation inside it, if animal is dog. Right, so we can do it just like this. Now, none of this would run if it's not a dog in the first place.
Okay, so we know that that A as dog will evaluate to a dog.
Yeah, that's exactly right.
But the interesting thing is A is dog just returns a Boolean. It actually doesn't do any casting or anything in and of itself. It just tells you whether this is a valid action.
And it chases up and down the hierarchy tree for you. It's very powerful, actually.
That is powerful.
Now, you might think that now we don't need to have if dog does not equal null, but null can actually be of a type as well.
Time flies when you're having fun, huh?
It really does.
It does. It's what happens when you start off with -40 on your timer.
That's exactly right. Is and as are pretty powerful that way.
Exactly.
Okay, so this is interacting with types, casting them, moving them around through the hierarchy. Let's do something with something else. Let's deal with strings.
Yeah, strings is a very common scenario where you need to manipulate strings.
Yes.
And so there's very rich support for string manipulation within the platform. But there are a couple of key concepts that you should bear in mind, because again, it can be expensive if you don't bear this in mind in terms of what you're doing. So a string object is immutable, and what that means is you cannot change a string once you've created a string instance. That seems counterintuitive in terms of when you might have some methods that can replace characters and so on. The key thing to understand is all of those methods actually return a new string instance.
Yeah.
Okay? And so that's important to understand. Again, if you're doing this in a lot of looping and so on.
Not all developers understand this, that when they do anything to a string and change it in any way whatsoever, a new string is created. They have not manipulated an existing string. They've taken that existing string, redefined it, created a new string, and put that new value in it.
Exactly.
That's the immutable. It's another one of those words.
Exactly.
You know what I mean?
Polymorphism, immutable.
That's incredible.
It's just lovely. So, what do you do if you know you're going to be doing a lot of manipulation when you're constructing a string? It seems silly to be using a string object knowing that you're creating objects, throwing them away, creating objects, throwing them away, and so on. Doing my little throwaway dance there. So the framework gives you another capability to do that, and that's the string builder.
Yeah.
So the string builder effectively models a mutable implementation of a string.
The string builder is a class that tries to solve this problem.
Exactly.
Because strings are so common. You're going to be interacting with them constantly, building first name plus last name or whatever.
Yep.
And we need some kind of pattern for it. String builder is that pattern.
Okay. Do you want to open up the string builder demo, or?
Yeah, let's...
Number 12.
All right, thank you. Number 12, got it. All right.
So what we've got going on here is we created a new instance of our string builder class, and that exposes a number of methods. We've got one that appends a line, and so what that does is it takes the string, passes a parameter, and appends it to any existing string content within the string builder. Because it's append line, it also adds the environment new line character to it. So if we were to squirt this out onto the console, then to use the technical term.
You're just contrasting append versus append line.
Correct.
Append line includes the new line character.
Indeed.
Got it.
Absolutely. We also have the ability to use formatting. So we have a loop here that's going to append a bunch of strings into the string builder. And why don't you put a breakpoint and run that through to that point so we can actually look at the content of string builder.
You got it. All right, so here we are, we're running. This is live.
This is live.
Go ahead.
So basically what we've got, if we actually look at the contents of string builder right now, down in the locals section, we actually see that there is that's the view into the buffer that the string builder is building of all the characters. And so we can actually see that there are new line and carriage return embedded between those lines of the first two lines.
That's right.
As we move through this loop, we can see that we'll be adding in additional strings.
And this is a pinned format, not a pinned line format.
Exactly. And so we will have to add our own line breaks if we want to actually make sure that these appear on different lines.
Okay.
What we can also see is we have a syntax in here that allows us to specify a format for injecting values external to the string into the string itself.
And this is something common even with just the string object itself.
Exactly.
Format is very powerful for constructing a string.
So we can see a couple of placeholders. We have 0, which indicates the first item that follows the string will be injected at this point.
So this is the 0 is the zero-based ordinal position, meaning this.
Exactly. And we've got a little comma there followed by a value, and what that does is it modifies the format of the value being output. And what this is actually going to do is increase the size of the number that's being output in that location to 5 characters in total, and it's going to space pad it.
It's nice.
It's kind of nice.
Yeah, it's nice. There's a lot you can do with formatting. Now I want to look at some of the other pieces we're doing. This is just candy that the string builder gives you, the ability to replace throughout the entire string, or you can treat them as individual lines. And then toString. toString is an impressive piece to where you've been building up this string and you need to generate the final result. That's where you do it. Now,
exactly.
Let's talk about ways of manipulating a string. So that's great with the string builder. Let's look at string manipulation, generally speaking. So this happens a lot. We get data back. We get data input from a user. We need to do something with it. And so the first one we can do is probably the easiest, and that's substring.
Yep.
And very common. Substring allows me to reach into a string and take any number of characters out.
And so bearing in mind what we talked about before, is substring just returning back the characters that are in there, or is it doing something else?
Well, if we were right, and we always are,
indeed,
then whenever we do anything that makes a change to a string, it creates a new string object.
Okay.
And so we say substring, it brings back only, in this case, the quick brown fox, only brings back quick. That is a new object that has quick in it.
Okay, that's interesting.
Yeah, isn't it though? Yeah, thanks. So also the string object itself has a static method of concat. This is a great way to bring two together without having to worry about how you're doing it. If you're doing it right, you can let the framework do it for you inside this method. Concat puts together the two values or series of values that you may have, concatenates those together and returns the object, the new object, with all of the items concatenated together.
And that's a good point, because when you were reading this, you would kind of think that you were concatenating fox onto the end of the value.
Yeah.
But it's actually the result of that is a new string. You're not changing value.
You could almost rename this to say string dot, create a new string object with these two values put together.
But that wouldn't be very succinct, would it?
No, it wouldn't. I'll talk about, you need IntelliSense for that.
Exactly.
All right, so we also have replace. This is a great one. Somebody puts in an invalid character, you need to remove it. Somebody puts in, a space and you need to remove it. You're good to go. Replace is a handy way to do it. Same as before, new object.
Yeah. I think everybody can probably work out what two upper does.
Two upper and two lower, changing the case. Yeah, it's really great. And what's nice is it reads the regional settings of Windows, and it does it properly. Right? It might actually be different depending on the language that you're actually changing.
Exactly. We have other convenience methods such as toArray. It's quite common to want to be able to iterate through a string character by character, and so this allows us to take the dog string and project it into a character array. So
these are kind of simple manual ways to do it. The high-end way, and with tons of capability, is certainly regular expressions. Regular expressions is in the text namespace. It allows you as a developer to be able to take a string and really interrogate it, to create patterns, and this is probably the neatest part. I'm not saying I want to go into this index and take this many characters. I want to find a pattern, things that look like HTML tags, things that look like people's names, things that look like addresses, and I can make very simple patterns that find a letter, or very complex patterns that find things that are only my invoice numbers that are in an email. Right? It's very difficult to find, but easy with regular expression patterns.
Or to match email addresses, so you could create expressions that map out what will be a valid email syntax.
Yeah.
And if you can find that match, then you know you've got something that matches that rule.
You can do that, and you could do that to validate data input as it comes in to make sure it does match. There are no matches, so they didn't type an email. You could also use it for nefarious reasons of like scraping the internet and finding all the email addresses out there. I've never done that, and I don't recommend you doing it, but I know some people do, and I hate them all.
Okay, sounds good.
Anyway, I will say one extra thing about regular expressions is Not only are they give you all this power, they are insanely fast. The performance of regular expressions is almost unexplainable, practically instantaneous. It feels like so fast, and so you would think all these new patterns and all that. It's a language of its own.
It is
those syntaxes.
Yeah, there's a lot of resources out on the internet that you can use to go and learn these things. And, obviously we're not going to touch and talk about how you create regular expressions and all the rules around it. But just understand that they are a very powerful tool, and the capabilities are exposed for you to use.
We could have a course on just regular expressions, and at the end of that course, you would still need the documentation at your hands, because the syntax is rich, and you got to keep a clear mind.
Absolutely.
Yeah. All right, so let's look back. We've done a lot in this module. We've done a lot. What have we done?
So we looked at controlling programmatic flow. So we looked at the different types of statements that can control where you go, what blocks of code are evaluated.
If statements, while statements, then breaking out with break and continue, return.
Exactly.
Sure.
So we showed that, those are how you can really control your program logic and determine exactly what your application behavior is going to be.
We also, remember, we also did a switch to do that, but then we kind of moved into what if it was an animal, and what if it was a dog? Where can we cast to? How can we safely cast?
So how can we really manipulate types and create those more common functions that operate at the base level, and then how can we specialize the types that have been passed in using is and as? Yeah, exactly.
And then some of those common behaviors or features or functions that developers put together to be able to go in, interrogate strings, to manipulate strings, find patterns in strings. Very powerful.
Absolutely.
Covered a lot this time.
Well, indeed we did.
But now we're going to cover 10 minutes of nothing. And so we'll see you in 10 minutes. It'll be Module 4. Is that right?
Module 4.
Module 4 in 10 minutes, and we will see you then.